This is the code for the singleton design pattern in Golang. Here I have created a singleton structure and created a variable named instance, which is a singleton pointer. And then I have created a method known as getInstance, which creates an instance when if there is no instance, then it will create an instance. Otherwise, it will return the instance which is already present. So by this, we'll have one instance running all the time. So in my main file, I have in my main function I have created two instances s1 s2 which are calling get instance, and when we run this we'll see that both the instances are pointing to the same, actually both the pointers are pointing to the same instance. So this is how it describes a singleton design pattern. This is our strategy design pattern in which it defines a family of algorithms and encapsulate each one and make them interchangeable. And we're implementing sorting algorithms over here. So in our design pattern, we have created a data set structure in which we have two variables, data and sorted list, and we have a function strategy. Uh, Here is the set function for data set in which we have set values for data and sorted list. And then this is our set strategy in which we are setting our first strategy, and this is for sorting, and this function will perform the sorting operation, and this is for displaying the sorted list, and this is for resetting the data, that is again changing the sorted list from sorted to unsorted. And then here is like a method for changing our strategies from bubble sort to merge sort and then to quick sort, and these are the functions for performing merge sort, and this is for quick sort. And here we have implemented three functions, bubble sort, merge sort, and quick sort, which will be our three strategies, which we'll send it to our strategy function in our structure. So here we are creating our first data set, and then we'll set the data and our first strategy. Then we'll do the display, which will show our unordered list, and then we'll perform the sorting operation, which will show the sorted list. Then we'll change the strategy from bubble sort to merge sort, and then we'll reset the data and display the unordered list, and then again we perform the sorting operation, and similarly we'll do it for the quick sort. So when we'll see the results, we can see that first we are having our unordered list that is not sorted, and then it is sorted by bubble sort, and then again the resetting is done. Then the list is again unsorted, and then we see the sorted list, which is done by merge sort, and similarly by the quick sort. So this is our strategy design pattern. This is our third design pattern, chain of responsibility, in which we build chains of the receiving object and passes the request along the chain until the object is handled. So here I have created an interface named handler, and in which I have handle request and set successor. Now I have created three structures: complete handler 1, 2, and 3. These structures will implement the interface, and they are implementing the handle request. So if the request R1 is sent, that is to concrete handler 1, then it will handle the request. Otherwise, it will send a request to the next handler. Similarly, if the request is sent to, then the next handler will get the request, and if the request is R2, then it will handle it. Otherwise, it will forward it to the next handler, that is concrete handler R3. And if the request is R3, then it will be handled by concrete handler R3. Then we have our main function. In the main function, we see we have created a instance of concrete handler 1, and here we are sending request, and let's see what our outputs are. So you can see that when we are sending our request R2, then it goes to R1 to R2 and it is handled by R2. Similarly, when sending our request R3, then it will go through R1, R2, and finally handled by R3. Similarly, R1 is handled by R1 itself, and when we send Rx, which is not defined, so it will go through all the handlers, and then then it will, but it won't be handled. This is the iterator design pattern in which it provides a way to access the elements of an aggregated object sequentially without exposing its underlying representation. So here I have created two interfaces, query result iterator and query results. And we have implemented these iterators using query result iterator implementation and query result implementer. So in query result iterator, we have four functions: first, next, current item, and is done. So in our so this is for setting the initial values of the query result iterator. So this will set the results to R and so cursor to 0 and maximum length to the number of items which are sent for the iteration. So in our first method, we are setting our array to 0, that is our first element, and then we'll check, the next function will move our list from first element to the next element and so on, and it will check till the last element, and if this if it ends, then it will return end, and the is done function is for checking that are we on our last element, and the current item will tell our the current item which we are on. So similarly, we'll implement the query result implementer, in which we are implementing two functions, fetch data and create data. Fetch data will get all the data and will append that data into our results, and then the create iterator will create the iterator, that is our first function which will be run for creating this whole process. So in our main function, we are querying like select all from test, and then when we'll execute this query, we are creating our first query result implementer instance, which will fetch the data and will create the iterator, and when the iteration is done, it will stop the iterator. So we'll see the output. So when we so when we query, we'll get all the elements in our list in the result list. So here is our chain of here is the iteration result.